All right, let's jump right into this explainer by confronting a massive pitfall in business, relying on simple averages. Today, we're going to break down exactly what a t-test is in statistics and its incredible importance. We'll unpack the core concepts and then walk through a simple manufacturing example to show you how this one statistical tool can literally save your company millions by keeping you from making the wrong call. Here's our roadmap. We'll hit the problem with averages, define what a t-test actually is, step into the statistical courtroom, run through that real manufacturing example, crack the code on p-values, and finally look at why this all matters. Section 1. The problem with averages. Let's see why simple math can totally pull the wool over your eyes. Imagine this for a second. How do you actually know if a process improved? Say you tweak a machine setting or switch up a raw material, and you check the new output. If you try to answer this just by grabbing a few samples and comparing the old average to the new average, you are playing with fire. Here's the deal. You just can't trust a basic average. Our source material points out a brutal statistical truth. Because of sampling variation, a completely stable process will literally never give you the exact same sample mean twice. Never. The differences you see are so often just random variation trying to trick you. If you're making decisions based purely on averages, you're completely ignoring the hidden variations bubbling right under the surface. Take a look at this. Here we have a stable, unchanging population distribution. You can see the total spread of all the individuals. This is reality. It's the true underlying behavior of the process. But what happens when we try to measure that reality? If we only pull 2 items from it, a tiny sample size of 2, look at how drastically different it looks from the real population. The average of just these 2 items would be wildly off the true center mark. Even if we bump that up to a sample size of 8, the shape and the average still shift around randomly. It's starting to look a little bit more like a bell curve, sure, but it is not the full picture. That is the pure chaotic noise of sampling variation. If you compared the average of the 2 sample against the 8 sample, you might swear the process fundamentally changed, but actually, you're just looking at the noise of the exact same underlying population. Section 2, what is a t-test? Let's bring in the heavy hitter to cut through all that noise. A hypothesis test, specifically the t-test, is how we mathematically prove a real difference. Conceptually, these tests are designed to calculate a signal-to-noise ratio. They compare the actual difference you observed, the signal, represented by the Greek letter delta, against the background noise of the process, the standard deviation or sigma. By doing this math, a t-test minimizes your risk of making a terrible business decision based on a random fluke. We've got a few different tools in the box, depending on what we need. A one-sample t-test compares your sample average to a historical target. A paired t-test looks at 2 dependent samples. But for this explainer, we're zooming in on the 2-sample t-test. It is perfectly designed for comparing 2 completely independent groups to see if they are genuinely different. Section 3. The courtroom of statistics. To really grasp how this works in practice, we need to put our data on trial. This concept perfectly mirrors a legal trial. When we run a t-test, we start with the Null Hypothesis, or H0. This is your statement of absolutely no difference. It treats your process like a defendant. It is innocent of changing until you have enough statistical evidence to prove otherwise. On the other side is the Alternative Hypothesis, or HA. This is the prosecution. It's what you are actively trying to prove, that the process is essentially guilty of changing. Section 4, a real manufacturing example. Let's see this courtroom drama play out on the factory floor with a scenario straight from our source material. Picture this. You're managing a manufacturing line. You need to figure out if there is a true statistical difference in the length of materials you're getting from 2 different vendors, supplier A and supplier B. You need to know if one is consistently giving you longer or shorter materials because getting this wrong directly impacts your final product. So you go out and pull 15 items from each supplier. Supplier A comes back with an average length of 10.099, supplier B, 10.310. The standard deviations are pretty much identical, right around 0.27. Now, if you were just relying on simple averages, you might immediately jump up and say, supplier B's materials are definitely longer. But hold on, remember our earlier chat? Is that incredibly tiny 0.2 difference a real signal, or is it just the sampling noise of 15 random items? We need the 2-sample t-test to tell us for sure. Section 5. The verdict. P-values explained. Time for the jury to decide. In statistics, the ultimate verdict comes down to the p-value. We take all that supplier data, plug it into the statistical software, run the two-sample t-test, and out pops a p-value of exactly 0.042. Okay, great, but what does that number actually mean for our business? Here is how we break it down. First, before we even tested, we set our acceptable alpha risk. Alpha is the probability of a type 1 error. Basically, the risk of saying the suppliers are different when they actually aren't. In the industry, this is almost always set at a strict 5% or 0.05. Next, we compare our p-value of 0.042 against that alpha threshold. And because 0.042 is strictly less than 0.05, boom, we have enough evidence to confidently reject the null hypothesis. We can state with 95% confidence that the defendant is guilty. Supplier A and supplier B are truly mathematically different. It is not just random noise.
Section 6. Why the t-test matters. Let's wrap this up and look at why mastering this is completely non-negotiable.
Check out this quote from our source text. It hits the nail right on the head. Businesses can no longer afford to make decisions based on averages alone. If you guess using simple averages, you are eventually going to make the wrong call. You'll dump a good supplier, or you'll ignore a massive problem because the average looked fine. The t-test gives you hard, actionable confidence instead of blind guesswork. As we close out this explainer, I want you to ask yourself something. Tomorrow, when you sit down and look at your own business metrics, your yields, or your supplier data, are you reacting to an actual, statistically validated signal? Or are you just wasting time and money chasing the random noise of averages? Once you understand the t-test, you know you're always acting on the truth.